and gentlemen, the human brain is the most complex object in the known universe. We use it all the time. We are prisoners of its whims, and our personalities are products of its functions. There are between 80 to 100 billion brain cells called neurons. Each neuron has 1,000 to 10,000 synapses or connections. 250,000 neurons are produced per minute in the early stages of pregnancy. Now, the brain has a sense of self called proprioception. This enables the brain to recognize when the body is touching itself. It's why we can't tickle ourselves. The brain generates between 10 to 23 watts of energy. That's enough to power a light bulb. It also has no pain centers, meaning we can operate on a person's brain while they're fully conscious. Now, the brain has a variety of neurochemicals which determine our moods and emotions. For example, 4 neurochemicals cause happiness: endorphins, dopamine, oxytocin, and serotonin. Each evolved to do a different job. Endorphins help us to mask pain. Dopamine sparks when we're near an important reward. Oxytocin is the feeling we human beings experience as trust. And serotonin is known as the general hormone for happiness because it contributes to the feeling of well-being. Now, we know some things about the brain, but the fact is that we know more about the universe than we do about this mysterious organ, housed inside each and every one of our skulls. It seems that we only recognize how peculiar the human brain truly is when it starts to malfunction. So I'd like to give you a quick overview on some of the most bizarre and outrageous neurological disorders that are caused when specific sections of the brain start to malfunction. When a person suffers from Cotard syndrome, he believes that he is dead. Literally. They have no sense of self. They feel absolutely no emotion towards anything. No person, melodic note, or article can make that person feel. A person suffering from Capgras delusion believes that a friend, spouse, parent, or other close family member has been replaced by an identical-looking imposter. This is caused due to damage in the connection between the fusiform gyrus, the facial recognition center of the brain, and the amygdala, which is the emotion center of the brain. Phantom limb syndrome just goes to show how bizarre the human brain can truly be. A person with an amputated limb still has the sensation that the limb is fully intact. Sometimes the imaginary limb even starts to itch. This may sound outrageous, but it is a widely documented and investigated phenomenon. Synesthesia is a cross-wiring between the senses of the brain. So synesthetes can smell sound. They can hear colors. And they can taste numbers. Damage to the vernix area of the brain causes aphasia, which is the inability to produce or comprehend meaningful speech and writing. Damage to the temporal lobe leads to the inability to recognize faces. This is known as prosopagnosia, or in other words, face blindness. Damage to the supramarginal gyrus leads to apraxia, which is the inability to propose purposeful movement and the inability to even imagine or think about proposing a purposeful movement. Damage to the hippocampus leads to the inability to form new memories, and damage to the amygdala leads to Urbach-Vita disease, which is the inability to feel any fear at all. Although these syndromes and several other properties of the brain are yet to be understood, we are making remarkable strides in understanding how the brain works. Brain scanning and brain imaging technologies are progressing at an exponential rate. And an astounding example of where brain research and neuroscience has gotten us is direct brain-to-brain interface. Let's go back to August 2013. On this special month, University of Washington researcher Rajesh Rao sends a brain signal to Andrea Stacco via the internet, causing Stacco's right hand to actually move on a keyboard. This experiment is proof in concept. We now have the technology to reverse engineer the brain signal and transmit it from one brain to another via computer. What's next? Well, how about the Human Brain Project? It aims to simulate the entire human brain on supercomputers to better understand how it functions. This will give us profound insights as to what makes us human, develop new treatments for brain diseases, and allow us to build brand new, revolutionary computing technologies. This project is well underway. We are already on the path to creating the impossible. Ladies and gentlemen, after considering how mysterious and powerful the human brain can truly be, I leave you with a question. How well do you think you know your brain?